Okay, class. Any questions? Questions? No? Come on, homework. Okay, which ones? Let's go. 61 and 65. We're working out of 6.1, correct? 6.2? Yes, 6.2. I'm sorry, you said 51 or 61, okay. We have 3x cubed minus 12y cubed. Is everyone okay with the light in the room? Is it too glary or anything? Board's okay? You can see it? Okay. All right, so what do we got here? How many terms? 2? You got a GCF there? 3? So you can pull just a 3, right? Pull just a 3 out, which leaves you with enough space there for 2 terms. What are those 2 terms? X cubed minus 4y cubed. And when you look at that now, you try and figure out if you can factor the inside. Now, in the inside, I have 2 terms, right? 2 terms. And the only thing we have for 2 terms is difference of squares, sum of squares, difference of cubes, sum of cubes. Because I have a minus sign in between 2 terms, I'm thinking difference, right? Difference of either squares or cubes. These sure as heck look like cubes, don't they? Right? Cube, x cubed, y cubed. So in order to break that down, I come over here and I say, I'm thinking, I need to make sure I can rewrite this as something cubed minus something else cubed. And those 2 things I would call my A and my B, right? And that's what would be going into the formula. So what do I cube to create x cubed? Just x, right? What do I cube to create a 4? I can't. See, 4 is not a perfect cube, right? 4 is a perfect square. 2 squared is 4, but what cubed is 4? And you're not going to be able to find it. Now, could you get the y cubed up there? Yeah, you could put a y here, but the big question mark is, what do I do to get the 4? And since you cannot, since 4 is not a perfect cube, that means we cannot factor it this way. We're stuck. And so, since it can't be factored further using a formula, that's what the answer. Yeah. Yep. Yep. Now, had that been an 8, you would have been in business, because then you could have put 2 here, right? Okay, and then the next one you said 63, 65. Did I really do that to you? I assigned 65? I'm just kidding. Yes, it's a beautiful problem. 8x minus 8 plus xy cubed minus y cubed. So at this point, I am thinking how many terms, right? And I have 4. Since I have 4 terms, what are you thinking if you got 4 terms? Grouping, but we always want to do what? GCF? Pull any GCF out. Do we have GCF? Nope. Not on all 4 terms, right? So I haven't split it yet. So I'm looking at this. I don't have a number that goes to all of them. I don't have variable in all of them. So no GCF. Is that all right? So I split it right after the 8. And then I look at the first 2 terms and I say, what can I factor out here? 8, right? So if I factor an 8 out, what am I left with? X minus 1. Now with grouping, we always like to say, whatever we get here, we're going to try and match it. So I put x minus 1 over here. And now I try and come up with something that will create what's up on top there. So how do I turn my x into xy cubed? Y cubed. And I put that out here, right? And it'll be a plus, a positive y cubed, so I should put that plus out in front. Remember, with grouping, you always had to have a sign there. Now let's just double check it. Old school, new school, right? Y cubed times x, that's it. Y cubed times -1, negative y cubed. So that does work, right? So I can rewrite this now, whatever they had in common, x minus 1, and then in parentheses, the two things that were in front, right? Now you're partially there, because x minus 1, well, that's just x minus 1, but this right here, you should start to automatically start to see like, oh, y cubed, right? 8 is a perfect cube. So these things should start being like little flashes in your nightmares, right? So you've got a sum, right, of two different cubes, two terms in there. So I can actually break this one down further. And I would do it like this, 8 plus y cubed over here. I need to see if I can rewrite that as something cubed plus something cubed. 2 cubed is 8, and then y cubed is y cubed. So that should work, right? A here in the formula, A is what? 2, and B is y. So according to the formula, which I'm not going to write down right now, but you should have had that written down, this should be A plus B, right? So 2 plus y. And then A squared, which is 2 squared, which is 4, minus A times B, 2 times y, plus b squared, which is y squared. Does that help? Okay. And that's it. We are done because this first one's not a difference of squares, right? This is not a sum of cubes anymore. This, what did I tell you about this? Do you remember what I said about this big ugly thing in here last class? We will never have to worry about whether or not that breaks down any further. It will never break down, so we are done. Questions? All right. Like I said, I do plan on giving you a quiz on the formulas we covered last class. And remember, it was a short class, right? I cut it off and I told you please watch the video. I don't know how many of you actually did it, but, well, let's see. Shall we? Should I even check? Well, it tells me who you are. No, it doesn't. It doesn't know. It doesn't know. It doesn't know. Remember I was saying I used to use the Alamo College. You had to, like a YouTube thing. It actually used to give me a report with IP addresses. So what I would do is I would give a quiz of watching the video, and then the students would have to come in the next class and turn in what their IP address was. And so I could check to see if they watched it. But I'm not, no big brother here, okay? I'm not. Let's take a look at my 12:30 class. Oh, wait. That's what? There are, aren't there? It's like we got nothing to do, man. It's not showing my number of views. 10 views. 10 views. Oh, I've got the wrong one? Oh, yeah, but it's on a different playlist. Hold on. That's that one right there. Thank you very much. Oh, 19 views. Pretty good. So good. I'm glad. I'm glad to hear that. Really? Well, I watched it 8 times. I go home and I just watch it. So, all right. Well, good. Hopefully it helped. If anything, it helped a little bit. Let's get back to our business, though. We are going to start a new topic today, and it's the next section, 6.3. Well, I'm actually going to skip. I'm doing 6.4 before 6.3. I know that doesn't make a whole lot of sense to you, but just trust me, I think it's going to work out better. 6.4, factoring trinomials of the form x squared plus bx plus c. Now, let me give you some examples of what this form is. I'm not going to show you, we're not doing the actual factoring, but I want you to see this section. We are narrowing our view just to certain trinomials that have a certain pattern to them, certain look. They have to look like that, x squared plus bx plus c. So here's an example, x squared plus 2x minus 4. Here's another one, x squared minus 5x plus 4. Here's another one, x squared plus 3x plus 2, x squared minus 5x plus 6. All of those have the same look to them, don't they? They're all trinomials. They all have, if you like, you could say a 1 in front of the x squared, don't they? They all have a 1 out here. And then there's always just some number in front of an x. Here it's, what, 2. The next one is negative 5. The next one is positive 3. The next one is negative 5, right? And they all have a number out here on the side, don't they? Agreed? Okay. Our focus today is factoring those types of things. So when we're done, you know, with, well, not just today, but next week also, when we're done, we will know how to factor binomials, 2 terms, trinomials, and then 4, right, which is where we do grouping. And we don't go beyond that in this class. You don't go beyond that until when, I told you? College algebra, right? That's when you start looking at things past 4 terms. So we'll almost be done with all of our factoring after next Tuesday. Okay, so before I do this, before I actually show you how this works, I want us to take a look at something. If I do, let's say, x plus 3 times x plus 5, and I tell you to multiply those two together, then you're going to do that thing we called FOIL, and I told you I didn't like FOIL, but a lot of people talk FOIL, right? And so the first step would be to multiply x times x, wouldn't it? And when I do that, I would get x squared. Now I would do x times positive 5, which would give me positive 5x. Then I would do the inner terms, positive 3 times x, which would give me 3x. And then finally, 3 times 5, positive 3 times positive 5, which gives me 15. Yes? Then I would collect my like terms together. My 2 like terms are here, aren't they? We add 5 x's to 3 x's to create how many x's? 8. So we get x squared plus 8x plus 15. Is everyone comfortable with that? The goal with factoring, right, was not to go from here to here, but we said to go from here back to this, right? Now, I want you to notice something here. There's a pattern, and this is what today is about, trying to recognize a pattern here. If I'm looking at the right side, so imagine nothing else, all you know is this. It's very difficult to know that that 8x came from adding a 5x and a 3x together, doesn't it? Like, how many different ways can you get 8x? Think about it. Do you agree this is true? X plus 7x is 8x? Do you agree that 2x plus 6x is 8x? You agree that 10x minus 2x is 8x? Right? So if I look at this and this 8x right here, looking at that 8x, I don't know that it actually came from 5 and 3. But there's something else here that helps me see it. What else? The 15. Because what is 15? 5 times 3. Do you see that? So the pattern that we're trying to see here is that this term in the middle, that number, 8, came from two numbers that when you added them, right, they gave you 8. But when you multiplied, you got 15. Now, how do I know that when you multiply them, I get 15? Well, where does that 15 come from? The 3 and the 5, right? That last step, 3 times 5. Do y'all see the pattern that we have in there? So the goal for us to be able to go from the right side back to the left is to be able to look at this right side and say, I need to find two numbers that have a certain property to them. The property is that they have to add up to be 8, but they have to multiply to be 15, right? They have to add up to be 8, but multiply to be 15. That's the basic concept of today, and now I'm going to kind of try and work through this with you. So let me start with this example. We'll start with that one. 8x squared, or x squared plus 8x plus 15. That's one way to do it, yes. Okay, let me tell you what happened in my 930 class. Like in the last year, the math department decided that we were all going to try and teach this concept the same way. Because what happens is there's all these different methods, and so I show you like my way, I like it, this is the way I like to do it, and then some other teacher teaches a different way, and then you go to the lab and tutor teaches a different way, and you have like 10, 20 different methods, and it can get confusing. So we all kind of agree to a certain method, and there's a handout for it and everything, and I tried it in my 930 class, and by the time we got through with it, we wound up back at what I normally do anyway, and so that's what I'm going to do. So just to give you a little history here, the 930 class kind of suffered today so that you just get the cleaned up version of what this is about. But yes, to answer your question, one particular way of approaching this, and the way I'm going to do it, is by drawing this X over here. And if this is a slight modification of what you've seen, then it's a modification. All this X does is helps you organize the ideas that we just talked about, right? We're trying to find two numbers, right? And those two numbers have to add up to be what? Hold on, be careful. Add up to be 8 and multiply to be 15. So we have to decide here in this little X what the way that I've shown it is I do multiplication on top and addition on bottom, meaning the 15, you just place a 15 right here, and you place a positive 8 here. And I would recommend you also put their signs on there. So we're trying to find two numbers, right, that multiply to be positive 15 and add up to be a positive 8. So this is where you have to actually think about it, all right? And we already know what the numbers are, right? But how would you come up with those numbers if it wasn't so easy? So one way of doing it is to take your 15, right? Take your 15 and just list out a table of all the different ways you can get 15. And start with 1. What's 1 times 15? 15. What's 2 times what gives me 15? Nothing, right? So 2 doesn't go into 15. How about 3? 3 and 5? How about 4? No? How about 5? Well, I already did that though, right? So you just work down this list until you get to a number you've already used. Do you all understand what I mean by that? 1 and 15, next one 3 and 5, next one 4 doesn't work, 5, I already used it, I'm done. So now you look at these numbers, 1 and 15. Is there any way that you could add these numbers together in any fashion to get an 8? 1 and 15. Just not going to happen, right? But 3 and 5? Yes. 3 and 5 will work. So what we do is we put the 3 here and the 5 here. And you can put plus and plus also. See, this cross is just a cute way of organizing your thoughts. That's all it is. If you can do this without the cross, you don't have to show it on a test. Yes. Yeah, you stop, yes. Because now all I could do is write 5 and 3, which is the same as 3 times 5, right? And then I could go and say 15 and 1, but that's the same as 1 and 15. So once you've gotten to this point, here's what you do. You write 2 sets of parentheses, okay? Then what was the variable that was being squared here? X. So you put X here, you put X here. That's the standard setup for all these problems. You'll have X, X, and then you use these two numbers, plus 3, plus 5. You put them right here. So X plus 3, X plus 5. And we already know that that's correct, don't we? Because we started with that. What do y'all think? Yeah? Okay, let me give you some. Let's start with the fresh one, so you don't know where it came from, and we have to work backwards. Let's see if I can trip you up. X squared minus 11x plus 10. All right, now let's not get ahead of ourselves, all right? How many terms? 3. Is there a GCF? No, so that's always what we want to start with, right? 3 terms, GCF, okay, we don't have that. Since there's 3 terms, I'm going to try this method where I do this little XC cross-C looking thing. On top is what multiplies, and on the bottom is what it must add to. So what are the numbers I'm going to put in this thing? No, I mean in this part right here. What do I need my numbers to multiply to be? Positive 10, right? And that comes from the number by itself. What do I need them to add to be? Negative 11, right? Negative 11. Any questions on where those numbers come from? Now, if you know the answer, don't spit it out yet. I need to try and find 2 numbers in my head, if possible, that multiply to be 10, but add up to be negative 11. Well, I'm a little confused. Let me write out a list of all the ways I can get 10. How about 1 times 10? Yes? Does 2 go into 10? 2 and 5, right? Does 3 go into 10? No. 4? No. 5? Well, I already used 5, didn't I? So I'm pretty much done. These are the only combinations that I can get, right? The only combinations. 1 and 10 and 2 and 5. How are you going to get negative 11 from these? Yeah, well, look, this is 1 and 10. If I add them, I get 11. So it's pretty darn close, right? I'm just off by the signs. 2 and 5, well, 7. Even if I subtract them, I'll get like 3 or something, right? So what's happening here is that we recognize that there is a way to get 11 from here, but we've just got to get the signs correct. So if you multiply 2 numbers together and get a positive number, what can you tell me about that? If I take 2 numbers, I'm not going to tell you what they are. Some number here times some number here, and I tell you that that's equal to a positive number. Can you tell me, is it possible for one of these to be positive and the other negative? No, right? Do they both have to be positive? They could be, right? But they could also both be negative, right? 2 negatives multiply to be a positive. 2 positives multiply to be a positive. So when I set up here, I need 2 numbers to multiply to be 10, it is possible that they're both negative. And that's great because if I do that, let's say I put negative 1 and negative 11 negative 10 like this. What do those 2 numbers multiply to be? Positive 10. What do they add up to be? Negative 11. Okay? Questions? So what does this become? X minus 1, x minus 10. Now, someone's inevitably going to ask me, could I have done x minus 10, x minus 1? What do you think? X minus 10 over there, x minus 1 over here. Yes, that'll still work because it's commutative. You can switch the order. Okay, let's try another. How about x squared minus 7x minus 30. Do you have 2 terms? No. 4 terms? No. 3? Yes. GCF? No GCF, right? I've been nice up to this point. No GCFs. So because it's 3 terms, I'm going to try this. I don't know why. I always want to call it a cross, but it's not really a cross, right? What is it? It's an X, a big old X? No. Whatever you want. On top is what multiplies, and over here is what adds. So what do I need on the top of that X? Negative 30. What if you forget to put negative and you accidentally put positive? It's over. Right then, it's over. The only way to get the correct answer if you mess that sign up is if you accidentally make another mistake that corrects the mistake you did earlier. You know? So make sure you pull the sign off that thing. And then what do you need those things to add up to be? Negative 7. Negative 7. So let's try and really think about this now. Before we go to start grabbing numbers. Negative 30. I have 2 numbers that multiply to be negative, right? What can you tell me if 2 numbers multiply to be negative? What can you tell me about those numbers? One has to be negative, and the other one has to be positive, right? It's the only way to make that happen. So the 2 numbers I pick have to be opposite in sign, one positive, one negative. Do you agree with that? And then I need to come up with the negative 7 when I put them together, which means that the one that's negative is actually larger than the one that's positive. So when you put them together, you get a negative. But that's a little bit beyond what I'm trying to get you to see. Let's try and come up with a list for 30. 1 and 30, right? Let's look at 1 and 30. Is it possible to get a negative 7 out of 1 and 30? No matter what I do, if I add them, I get 31, right? If I make them both negative, I get negative 31. If I take 30 and subtract 1, I get 29. If I take 1 and subtract 30, I get negative 29. There's no way I'm ever going to get close to negative 7 using those 2 numbers. So let's try the next number. What, 2 and 15? Okay. 2 plus 15 is 17, so I'm not close. If they're both negative, well, wait, we said they couldn't both be negative, right? But even if they were, that'd still be negative 17. How about if I subtract 2 minus 15? Negative 13, or the other way around, 15 minus 2 would be 13. So there's still no way, right? Next. 3 and 10. You add those up, you get 13, right? However, do you all see it? If I take 10 and subtract 3, I get 7, don't I? But I need negative 7. So what if I do it the other way around? I take 3 and I subtract 10. Won't that give me negative 7? And we said one had to be negative and one had to be positive. So I'm going to put up here, I'm going to use the 3 and I'm going to use the 10. I just got to get the signs correct. So which one's going to be negative? The 10. And I'll put the plus on the 3. They call this the kind of, they call it a kind of guess and check method. You're not guessing, okay? It's not a true guess. It's an educated guess. You're kind of like messing with numbers, and then you're saying, the 3 and 10 kind of look like they'll work. That kind of gets me a 7. I put them up there, and you start to try and mess with the signs to make it happen. Then you put it in. So what do we get? Plus 3, x minus 10. And of course, you could always check these by multiplying them out. Foiling. Next. Questions? Negative x squared plus x yeah. Plus 72. You help me. You guide me through this one. Okay, hold on. I'm listening. I heard you say no GCF, right? Okay, so we're always thinking GCF first, right? We're also thinking 3 terms, which means we're going to use this big old X. But does this look like what I told you today everything had to look like? What's wrong with it? It doesn't have a 1 in front. It has a negative 1. And we do not like that, because I didn't say you could do that for negative 1. I said it could only work, this method right now only works for 1 in front. So what we're going to do is we're going to get that negative 1 out of there. How are we going to get the negative 1 out of there? Change the sign. So we're going to factor out a GCF. We're going to factor negative 1 out. We've done that before. We said you're free to do it. All it does is changes the signs of everything, doesn't it? Like that. So by taking a negative out and putting it in front, you got to put it there. It can't just vanish. It's got to be written out front. Then the negative x squared becomes positive. The positive x becomes x, a negative x. Positive 72 becomes negative 72. Now, with what's inside there, does that look like what we've been talking about today? Yes. So now I'm ready to make my x over here. What would you like to put in the top of that x? Negative 72, and in the bottom? Careful, careful, careful. What is it? Negative 1. So we don't care about the x, right? In all problems we've done, we never pulled the x down here. We just pulled the number in front. So that is a negative 1. So we put negative 1 down here. I gave a quiz last class, right, at the end? And I voted, they voted, and I said, how many of you would like one of the problems that we did today on the quiz? And they were all like, yeah, we'll do one of those. And it was a problem just like this. And so many people looked at this, and they put like negative x down here, or x, which it didn't necessarily make them mess the problem up, but technically that's not what we were doing, right? It's the number in front of x, not the x itself. All right. This part of the problem at this point depends a lot on the student, on you. How comfortable are you with arithmetic? Because that's what this is. This is arithmetic. Do you know the factors of 72? Do you know all the numbers that multiply to be 72? The more you know, the quicker this is going to go. But maybe you need to make a table. So if I'm going to make a table for 72, I can go 1 and 72, right? Is that even going to get me close to 1? Or negative 1, I should say. No? Oh, and one of these should be positive and negative, right? 1 negative, 1 positive. Why? Because I have a negative on top. Does 2 go into 72? 2 and 36. Can we get a 1 out of that? Not really. They're really far apart, right? 2 and 36 are really far apart. 3 go into 72? 24 times. Does 4 go into 72? What is it? 18. Are any of these getting close to 1 when I add them or subtract them? No, but they're getting closer, aren't they? Like, when I say getting closer to 1, what I'm saying is 4 plus 18 is, what, 22? But if I subtract them, I'm getting, what, 14? Up here above, when I subtract them, I get 21. So, I started out, the difference between these two is 71, then 34, then 21, now 14. And as I keep doing this, looks like they're getting closer together. So the difference between them is getting closer and closer to this 1. 5 doesn't go in there. How about 6? 6 and 12? No, that doesn't work. 7? 8 and 9? Well, there you go. Right? 8 and 9. It's all the way at the end of the list. Why? Because I wanted you to go all the way to the end of the list. So I wanted to make a problem that forced you to kind of go through all the different combinations, unless you saw it right away. If you saw it right away and you thought you had, 8 and 9, yeah, that's it, 8 and 9. Now I just got to mess with the signs a little bit now. So there are candidates, 8 and 9. I just got to get their signs right. So I'm just going to throw up here, throw up into the X these two. Now, which one's positive, which one's negative? Negative is on the 9, positive is on the 8. And we're done. How does this feel so far? I mean, are any of you like, oh, this is really going to suck, or does it feel like this is maybe better than what we've been doing so far? Yeah, a little bit. Like those formulas are kind of weird, I guess. To get the two numbers. Well, I mean, that's why I was saying there's so many different methods for it. The ultimate method would be this. I mean, this is the greatest method there is. That's x plus 1 times x plus 5. That's the greatest method. Why? Because I've done so many of these problems, I just know it. I just see it. Okay? And that's what you try to get to as a student. This x and everything is just to organize your mental process. I wrote that problem down, and when I wrote it down, when I created the problem, the first thing I did is I created this, and I just made up 6 in my head. And then I thought to myself, I just need a number now that multiplies to be 6. I mean, that multiplies to be, sorry, when I add the two numbers, I get 6. When I multiply them, I get 5. So I just have 5 and 1, right? If I make up this problem, x squared, boy, I get lots of students with this one. Lots of students get that one wrong. What do you think most students want to use? 2 and 3? Or it's 2 and 3 or 6 and 1, right? Let's scratch this one out. It's 6 here and negative 5 here, right? Isn't that what this is? 6 and negative 5? What are the different ways you can get 6? 1 and 6 and 2 and 3. That's it, right? And you might look at this and say, 1 and 6. There's a way I can get 5, right? And 2 and 3. Oh, but wait, that's also another way I can get 5. So which one's correct? Do y'all see what I'm saying here or not? 2 and 3? But it has to, you can't put 2 and 3 because it has to add up to be negative 5. So you'd have to do what? Negative 2 and negative 3. Does negative 2 and negative 3 multiply to be positive 6? Does it add up to be negative 5? Yes, that's correct. Now what do I see the mistake? Things like this. 1 and negative 6. People will be like, I got it, negative 5. 1 and negative 6, I got it. But when you multiply them, what do you get? Negative 6, that's not what we have. So let me get back to answering your question. Is there an easier way? I don't know. I mean, it's hard. It's so much about your brain, about the way your brain functions. If you have a real problem with sign numbers, just arithmetic on integers like, 4 times 8 and, 7 times 6, and all those basic integer multiplications. If you don't see all that in your head, this is a slower process. And it's a checking and writing out tables and trying to figure it out. If all that's just kind of automatic to you, you can do all these problems usually without writing a single thing down, which is what you want. In a college algebra class, if I write a problem, well, this one would trip some college algebra students up because it's designed to. It's actually made just to confuse people. I like to use that problem to like humble people when they're like, oh, I got all this, and then I give them that, they're like, oh, maybe I don't. You know, I'm just making one up here. So when I'm making this up, I put -4. So the two numbers I need to pick need to have separation of 4, difference between them of 4. So someone give me two numbers that differ by 4. What? 3 and 7? What's 3 times 7? 21. So I'm going to put -21 here. There we go. So let's see how quick we can come up with the two numbers. How can you create a -21? Or just look at it as 21 if you want. 3 and 7, right? 3 and 7. Now, can you make those somehow combine to give you a -4? -7 and +3. So let's just try it. Let's just throw it into some parentheses real quick. What's x? So -7, x plus 3. Does it work? X squared, right? 3x, take away 7x is -4x. Our last term, -7 and +3, is -21. It works. Would this work? This is a new problem. How can you get 21? Well, 7 and 3, right? So maybe you try it, but what's the problem with this one? If you do 7 and 3 like this, the problem is that you need the last number to be positive, don't you? So this 7 and this 3, you can't have one of them be negative. They either both have to be positive or both negative. So is it possible to make this happen? It's not. I mean, even if we write 21 down here, 1 and 21, 3 and 7, are there any other numbers? There's no way to combine these to get a +21 and a -4. But if me doing it this way, the way I'm doing it right now, and talking through it, if that's kind of confusing you, that's why that X is there. It's to organize the ideas. So what would we say in this problem? What do you think we'd say if we try this and it doesn't work out? We had another name for it. Remember sum of squares? Prime. We'd say this is prime. If it cannot be broken down, then it's prime. How about this? X squared minus 21x plus 20. Without telling me the answer, does anyone have this mentally already? Yes? Then this is probably not the first day you've ever done this, right? Or seen this, right? Yes? Okay, good. Anyone else get it yet? Yeah? Tell me if you get it. We've got 2 people who think they've got it. We're shooting for 20 here, right? Positive, and -21. The numbers that I know multiply to be 20 are 1 and 20. 1 and 20 is 21, isn't it? But I need it to be negative 21, which means I would have to do what? Make them both negative. Negative 1 and negative 20. And a negative times a negative would give me positive, which is what I need. Negative and negative here add up to be negative 21. So that appears to work. X minus 1, x minus 20. I'm going to do it off the quiz today again. We have 25 minutes. I don't want to get into the next topic, but I want to really make sure you know how to do this or get some practice before you leave. So what I'm going to do is I'm going to put up a couple of problems for you to work, right? And I think what I'm going to do is count that as your quiz grade. I'm going to spare you the quiz today. But I'd like for you to try and, get these done. I expect you to finish every single problem I put up here today before you leave. It's going to be over just what we went over right now. Yes. Yes, that is the homework on the board, by the way. Yes, it is. That's from my other class. I never erased it. Page 429, 15 through. So I'd like for you to do the following problems. X squared plus 10x. Let's see. Who does not have a book at the table? Is everyone? Everyone have a book? Okay, good. We'll just do out of the book. Page 429. Let's do 16 through 36 even. That's 11. That's 11 problems. See what you can do in 22 minutes. Oh, my computer